The broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS, welcome to this webinar on Test-Driven Development Exposed. I'm Rex Black, President of RBCS. We are a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we've delivered insight and confidence to hundreds of clients around the world. Our team of international consultants deliver customized training, consulting, and outsourcing services to companies that are looking to improve their test and quality assurance practices. I'm the author of 12 books on software testing, including the bestseller Managing the Testing Process and 4 books on the ISTQB program. Please note that today's webinar is a technically focused webinar, and therefore there are no PMI PDUs associated with this webinar. Before we start the presentation, a couple notes. If you have any questions during the course of the webinar, feel free to submit them throughout the presentation via your webinar interface, but please note they are answered only at the end. You do not need to ask for presentation copies. The presentation is on the web. Go to rbcs-us.com. Navigate to the Resources tab in the upper middle. From there, navigate to the Basic Library, and you will find PDF version of these slides posted there. By attending this webinar, you have been automatically registered for the free e-learning drawing. Check your email over the next couple days and watch that spam filter. I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are a not-just-for-profit company. Okay, so TDD, Test-Driven Development. What the heck is that? Software engineering is certainly a young and rapidly evolving field, we are susceptible, like any field is, but especially I think as a younger, more rapidly evolving one, to the sort of fads and buzzwords, and you may be familiar with Gartner's famous hype cycle, and so ideas come and go, and certainly one of the things that's been somewhat controversial, spurred a lot of discussion, Twitter storms and so forth, and being accused by some as being just one of these passing fads is test-driven development, or TDD. Now, part of the confusion about this is that there's sort of this alphabet soup of ATDD, BDD, TDD. What are those things? Are they the same thing? So one of the things I want to do today is try to clear up any confusion that might exist about what those three things are, how they're different. Also, test-driven development, it could sound like, oh, I'm a tester and I want to be driving the developers and I want to tell the developers what to do. Well, that's not at all what it means, as you might imagine. Developers are excited about TDD, at least some of them are. No developer would ever be excited about testers telling them what to do. So it's not that. And there's really another issue that we need to look at here, which is whether test-driven development is even actually testing, or if that word at the beginning is sort of a misnomer. Now, TDD came out of the Agile world, specifically extreme programming, but it can be used in really any development approach. It's not specific to Agile. I mean, you could be doing Kanban, DevOps, whatever, and use TDD, or at least the developers could. So it's a development technique more than a testing technique, as we'll see as we go along here. So the way it works, it's sometimes called test-first development or test-first programming, though the true proponents of it, I'm sure, would want it to be called TDD, or test-driven development. So the way the process works is, I'm sitting down to write a new module, some new object, say, for my program. Now, classic programming says that I'm going to write the code and then write a unit test for it. But TDD stands that on its head and says, no, write a unit test first, and don't write a unit test for the entire module that you're going to build, but write it for a small piece of the module, and then run the test. Now this seems bizarre because the code, you haven't written the code yet, so of course the test is going to fail. But one of the things that this tells you, that by running the test it does fail, that it actually is checking something that doesn't exist. If it were to pass, clearly there'd be something wrong with your test. So it's sort of a way of confirming that your test knows what it's doing. Then you start writing code, and you write code, run the test, write code, run the test, write code, run the test, until the test passes. And then you would go in and look at the code and say, okay, I don't like this part of it. It just, that doesn't look right to me. I would, I want to clean it up a little bit. The Agilists refer to this as refactoring. And excuse me, so you do that and you run the test as you're making changes, and then once you're happy with the code and the tests all pass, you then add another test for another little piece of what you're about to create, and run all of the tests, both the existing ones, which should still pass, and the new test that you just created, and then that should fail, and then you start the process over again. To the extent that you are seeing tests fail, you're fixing the code right away. There's no intermediary step of logging a bug. As resistant as developers are to logging bugs against code, logging bugs against failed tests that occur during unit testing, they're even going to be more resistant to any suggestion that they do so here. And in fact, in this case, I would tend to agree, because they're not really bugs. If the tests are failing, it's not really a bug. I mean, because the code isn't done yet. So you're still building the code, so there's no reason really to call that a bug. Now, effectively, what you're doing, if you're following the approach that I just described, is specifying the expected behavior of your code using tests, using a test harness like JUnit or CPP unit or NUnit. There's a whole these different, I'm going to call it the XUnit frameworks out there, these open source tools that allow you to build these automated unit tests. So effectively what's happening is, you could call them tests, but they're really more like an executable design specification. And then what should happen, and typically will happen if you're in an agile world, is that those tests, once built, when the code is checked in, the tests are also checked in, and they're part of your continuous integration framework and used to reduce regression risk. Now, more on that later, the extent to which that regression risk is actually reduced by such tests. Okay, so something that sounds a lot the same but is actually completely different is acceptance test-driven development. So, okay, it says test-driven development. What's acceptance test-driven? What does that mean? Well, in a agile development world, you're supposed to have user stories, which are, little teeny chunks of functionality, smaller even than a use case, that are going to be added as the system's being built. And it's being built by these small little building blocks of user stories. And the user stories have what are called acceptance criteria, which are supposed to be defined collaboratively between the developer, the tester, and the business stakeholder. So you've got your acceptance criteria, and so the acceptance criteria say, all right, this is what's supposed to happen if the thing works, but there can be ambiguity about what those acceptance criteria really mean. So acceptance test-driven development is about creating an actual concrete set of tests, specific input values with specific expected results that can then be shown to the business stakeholder and the developer by the tester, who's the one creating these tests, to say, okay, do we agree that this is how it's supposed to behave? Now, this technique is also sometimes called specification by example, which is perhaps a little more illustrative of what's happening here, because you are basically saying, okay, this specific set of circumstances, this is what's supposed to happen. And so that's a concept, by the way, that goes back some distance. I mean, this is, the early 90s, late 80s. There was a sort of idea that test design should lead software development, that test design should be first, because by designing the tests, you basically are making specific what the system is supposed to do and removing any ambiguity that might result in the developer creating something different than what the user, customer, requirements author had in mind. Now, these tests, once created, can often be automated using tools like fitness, so in parallel with the programmer creating the code to implement the capability described in the user story and the acceptance criteria, the tester is now automating the tests that are described in this ATDD tests. And those automated tests can, in some cases, be run the first time the code is delivered for a system test. So this is kind of a testing nirvana, that you're able to actually use your automated tests for the first go-round of functional testing, and then those tests can be put into the continuous integration framework as well, and now that becomes an ongoing part of the regression risk mitigation strategy. These tests can run at a data layer, at a service layer, the user interface layer, so there's really no dependency on graphical user interface here. You can be testing it at whatever layer happens to be accessible. So this is complementary to what TDD is doing, because notice that this is specifying behavior, externally observable behavior, right? Versus you've got the TDD tests, which are really structural tests. They're white box, as opposed to the ATDD tests, which are now black box. They're based on how the system's supposed to behave. We don't care how it's implemented. The unit tests are going to be very specific to how the code works. Okay, so now we've got the BDDs: TDD, ATDD, SBE, if you prefer, specification by example, and now BDD, or behavior-driven development. Now this is another black box approach, though in this case the developer is going to be involved in creating the test to some extent. Now there may be that the tester might be involved as well, and if the tester is sufficiently technical, then the tester might actually do all of the test development. But again, this is something focused on behavior, and it'd be complementary to TDD. So this is something that could be created perhaps after the TDD tests and the code itself are created. Similar to ATDD, these BDD tests are supposed to be readable by testers and business stakeholders. They should not require an ability to read the code. Now, TDD is different because you would need to understand the tool, and you need to understand the programming language being used, and even then, reading it might not tell you a whole lot about what the system is supposed to do. It tells you about what that individual little module is supposed to do, but it's not going to tell you about what what business problem the system is supposed to solve. Unlike ATDD and BDD tests, which are going to be about specifically what the system is supposed to do for the customer, user, etc. Now, what is going to happen here is whoever's developing these BDD tests is going to take the acceptance criteria in the user story and express behavior under certain circumstances. So given some context, when some event occurs, then the system should do something. So given that, as an example, let's say we're testing an e-commerce application, we could have a BDD test like this. Given that the customer has one or more items in their cart, when the customer clicks checkout, then the first of the purchase screens is displayed. So notice that that's about something that's we've got like a precondition. We have this thing that happens that is basically this event that triggers the system to do something, and then we have, okay, this is what's supposed to occur. So again, this is an observable behavior, and the developers, the testers, and the business stakeholders can use this as a way of communicating about what the system is supposed to do. Now, these three things are potentially all usable at the same time. So you could have a situation where TDD, BDD, and ATDD are in practice. My experience as a consultant has been that usually our clients are either doing ATDD or BDD, but not both. And in some cases, I've had clients tell me that they tried to do BDD, they found it too difficult to maintain the tests, and they switched over to doing ATDD. Now, that's by no means a huge survey. I'm talking about a few, 4 or 5 anecdotes like that, and whether that they had problems with BDD because BDD is inherently difficult to maintain under some circumstances, or if they just had problems because they were doing it wrong, I don't know. But take that as an input if you're considering these. But notice that whether you're doing BDD or ATDD, that would not have any influence on whether the developers would potentially be applying TDD, since that's about the development of the code and a test at a unit level, whereas BDD and ATDD are more system level tests, or to use the Agile testing quadrants theory, you say TDD is quadrant 1 testing, and BDD and ATDD are quadrant 2 testing. Okay, so just to go a little further into the process that I described briefly before, if you're just getting started doing programming with TDD, the first thing you would need to do is set up your unit test framework. So you get your JUnit or whatever tool it is that you want to use, and then you're sorry, I just had something bizarre go on here. You get the tool that you're wanting to use, and you get that set up, and that's going to be the first step. You're then going to, when you're sitting down to create your module, you're going to define the steps that you need to carry out, and that is going to then lead to the kind of tests that you're going to need. And we're going to look at that a little more in a subsequent example of what that might look like. And then, as I said, you create the tests one test at a time. To create the test, run the test. It should fail. Write the code that will make that test pass, and just the code needed to make that pass. No, excuse me, no additional code. and then, tweak it, make sure that you're happy with the code the way it looks, continue to run the tests, and then go on to the next unit test. And ultimately, when you're done, all of this, the code and the automated tests, get checked into the continuous integration framework. Excuse me. Sorry, I was just checking something on the console here. I did rather bizarre looking message from GoToWebinar that seemed to indicate that you guys weren't seeing what I thought you were seeing, but now it's saying that you are seeing what I think you're seeing. So maybe somebody needed to do a little more TDD on that. Okay, so as a consultant, I get to travel around and talk to people both in a training setting and doing consulting in their organizations. And so, I hear people say, oh yeah, TDD, our organization uses TDD, our developers use TDD. Then sometimes I drill down into that, and it turns out that that somebody has heard the phrase TDD, test-driven development, and they think that's what's happening, or it would be cool if that was what was happening. But basically, all that's really happening is some amount of automated unit tests are being created. Sometimes that means that the unit tests are being created, but after the code is written. And sometimes it means, oh, well, we have this continuous integration framework, and there are some automated unit tests in there, and they get run, so that must be TDD. Well, of course, it's not really, because it's the TDD process requires that the tests be created first. Now, one of the things that I always listen for are fairy tales about unit testing of one kind or another. So one that I hear is, oh yeah, we create unit tests unless the code is too tightly coupled, and then it's too difficult. That to me is often the beginnings of an excuse, because that's sort of a get out of jail free card for the developers, and they don't actually have to create the unit tests. Oh yeah, my code's too tightly coupled. I wrote it tightly coupled, and now I can't unit test it. Maybe you shouldn't have written it that way. Another one that I hear an excuse is, well, we'd really like to use TDD, but there can't be any frameworks for our language, which is an excuse as well. I mean, I was recently doing some consulting for a client, and they kind of trotted out this, well, we really can't do unit testing because we're this is SAP. And I'm like, well, I'm pretty sure that there's probably something out there. And yes, there is one of these XUnit frameworks for the SAP programming language. So, unless you're doing something really bizarre like using APL or something like that, I'm pretty sure that you're going to have a framework available for you. And, plus you don't really need the framework to do it. I mean, you can just write tests in the same language. And then, of course, there's the, when managers say things like, oh, yeah, TDD, it sometimes can just mean, I have no idea what TDD is, but, I've heard developers talking about it and saying it's something really cool, so, we must be doing it. Now, to me, as a consultant, I'm looking for the excuses, because I'm always worried that we're not fully taking advantage of opportunities to find and remove bugs early. And organizations that aren't doing that, I kind of say, hey, you really shouldn't be throwing all these bugs over the fence to the developers or to the testers. As long as the first three things are in place, continuous integration framework, unit tests, automated unit tests, and that are placed in that continuous integration framework, I think that you're going to get some solid benefits out of that, though there can be limits to that, as I'll discuss a little later. But, I'm not a purist. I'm not one of these people who's going to say, oh, well, unless you're actually following, the exact way of doing TDD as, is described by people like Ken Beck and some of the other high priests of TDD, then you need to be excommunicated from the school of the cool kids. I just really don't care. To me, what I care is whether what they're doing is working for my client. If it's working for them, then they're doing it right. If it's not working for them, regardless of whether they're following the steps written down in a book by somebody who never visited their company, that's not really the point, right? I mean, if it's working, it's working. If it's not working, it's not working. If it's consistent with some sort of doctrine that somebody's putting forward, well, that's not what I'm interested in. I'm interested in engineering, not dogma. Now, so with all of that said, one of the things I want to come back to here is TDD really testing? Well, maybe not. So, some questions here. In testing, we generally have this concept of the test basis, or plural test bases. These are the things that our tests are based on. Well, what are the test basis documents here? Well, there's a user story and there's acceptance criteria, but those are describing behaviors. They're pretty far above the observable workings, if you will, operations of an individual unit. So the test basis here really is the programmer's brain. And so they're writing that down. Instead of writing a design document, they're writing tests, but ultimately that's what those tests are expressing, is their design decisions. Now, we also typically in testing have this concept of a test oracle or test oracles, which is the things that are going to tell us what the expected results are. And here again, we don't have that, other than it's the judgment of the individual developer who's creating these TDD tests. They're defining the tests, they're defining the expected results. These are basically just design decisions that are, again, as I said, being captured in some J unit or N unit or CPP unit or other unit testing framework. So, are those really like classical tests? Do the developers actually know any sort of test design techniques? Often not. So these tests that are being created, again, are they do they cover the equivalence partitions? Are they focused on boundary values? Do they look at ways conditions combine to produce particular outcomes? Or do they look at domains or states? Probably not. So that's kind of an issue, that they're basically not informed by any sort of test design technique, other than just what occurs to the developer. And typically when we're creating tests, we want to create both positive and negative tests, testing that the system works under normal conditions, but also that when we throw certain curves at it, it can handle those and respond properly. And is that going to be done here? Maybe not. Kind of depends on how clued in the tester is, or the developer is. Excuse me. Code coverage. Unless the developer is actually using a code coverage tool, will they get to any particular level of code coverage? Questionable. Now, certainly, one of the things that has been good is I have seen a lot of these continuous integration frameworks that do deliver code coverage metrics, but is the developer being careful to make sure that the appropriate level of coverage is being achieved? Not always. And sometimes they don't even know how to interpret those. I've had a number of developers be unable to articulate to me the difference between statement coverage and decision coverage, which is a pretty fundamental difference. And an example which can be used to illustrate the difference is trivial. It's basically just an if statement without a corresponding then block. So, you know, so we're not necessarily going to get to high levels of code coverage. TDD by itself does not require static analysis or code review. Now, you know, we would hope that those would be there, and certainly we see with the number of our clients that they do use static analysis tools, and that there are some code reviews. But you know, often these static analysis opportunities and code review opportunities are really underutilized. So, you know, to me, given that you know, don't have really solid answers to these questions, again, what you have here are just executable design specifications and not really tests. If you were to enhance the answers to these questions, if it were, have better test bases, test oracles, use good techniques, make sure that you're trying both happy path and unhappy path, measure coverage, combine TDD with good static analysis techniques and good code reviews. And by good code reviews, I'm not just talking about your boss looked at the code, you know, briefly before it was checked in. You know, these are all things that would raise the game, but I think that a lot of the developers that I've spoken with wouldn't actually be able to do this by themselves. Now, more on that a little later. Now, since the developers wouldn't really be able to do these things by themselves, how would you make TDD tests into real honest-to-God tests? Well, I would say that you have testers involved in the process. And so what that would mean is that they would you know, participate in the review and suggest improvements to the TDD tests after the coding was done or while the coding was going on. Now, in order to do this, of course, tester would have to be able to read the code that the system is being programmed in. So there's an element of code literacy. Now, sometimes testers really get worried when I say that, like, oh my God, I'm going to be a programmer. Well, notice I'm talking about being able to read it and understand what it says, not necessarily being a you know, great programmer yourself. Just like, you know, I don't have to be Hemingway in order to read Hemingway, but I do have to be able to read English. So being able to read the code, understanding how the unit test tools work, understanding the code coverage, and not just at the like ISTQB foundation level, but more of the technical test analyst kind of understanding of the code coverage metrics. Being able to look at static analysis results and go, oh, okay, we have some maintainability issues here, you know, knowing what cyclomatic complexity is and when complexity is too high. Knowing how to bridge the gap in terms of the test basis and test oracles for the TDD tests. And being able to effectively participate in a code review and provide feedback on the code. These would all be things that testers would need to do to be able to contribute to TDD to a greater or lesser extent. Now, you don't have to be you know, expert at these things right from the start, but you need to be competent. A lot of organizations, software organizations that I've been in, really have a very meritocratic kind of approach. You know, your status in the organization is earned by demonstrated competence and capability, especially in technical things. So you don't want to be in a situation where you're seen as not particularly competent. You're showing up at code reviews and making comments that aren't really, you know, that don't indicate a real good understanding of what the code means. But, you know, basic competence is okay to start with. Now, another advantage of being in the loop here with these TDD tests is that when you go to create your tests, say using BDD or ATDD or whatever other tools you're going to use, you want to try to complement the coverage that TDD tests are providing and certainly not duplicating it. Now, let me give an example of TDD in action here. I originally was going to illustrate this in this presentation using actual code, and then I realized, well, that's not going to really translate well to a lot of you guys out there in the audience who wouldn't necessarily be able to read the code, so I did it in English, but you'll get the basic idea of how this would work. So let's suppose we're building an e-commerce application, and certainly in an e-commerce application, one of the things we're going to need to be able to do is process payments using credit cards and debit cards. So let's suppose that we've got a online payment processing service that we're going to use, and we have a programmer now who's going to use TDD, and they're going to create a module to access the service and to process payment. So what do the steps look like here? Well, we're going to follow that process that I described before. Write the test, write the code, then refactor, right? Write test, write code, run test, refactor, that tight loop that I showed. So let's say that the first thing that we do is we're going to verify valid input parameters. So the module is going to have to take things like credit card number and name and card verification code and expiration date and amount of the transaction. So we'd want to have some checking that the input parameters were correct first before we pass them off to the web service. And so there might be one step here. More likely it's probably multiple steps here, so there's maybe 3 or 4 steps involved in doing this. So you write a test, you write some code, again, run the tests. Okay, it works or it doesn't work, fix that, right, move on to the next step. So we get that working, and then we move on to the establishment of a connection with the web service. So again, we would write a test to check to see whether the connection had been established, run that together with all the previous tests. All the previous tests should pass, and this new test should fail. Now we write the code to establish the connection, and then clean it up, refactor it as we see fit, and then move on to the transmission of the parameters. Test for that, write the code for that, and then test for handling successful transactions. That's probably a fairly straightforward there when it works. And then we add the handling unsuccessful transactions, and again here there's probably multiple steps, since there's probably multiple return codes that could come back that indicate some sort of problem that occurred. So as I said, the tests are going to provide executable specifications for the code. So it would be possible to take the tests and ditch the code, throw away the code, and then rewrite the code based on the tests themselves, because the tests basically are going to say this is what's supposed to happen. Would you write the exact same code under those circumstances? Probably not. But it would be very similar in terms of the way it's built, because the tests are tightly linked to the way that the software is implemented. Now, will these be real honest-to-God tests? Again, depends on whether they have some traceability back to identifiable test basis documents, test oracles, the ability to measure coverage, the designed using real test design techniques and so forth, but they could be. Okay, so I mentioned that there was controversy. So far I've been just kind of talking around the edges of it, really, and describing the process, and dipping a toe into the controversies and then quickly backing out. I mentioned this thing, I'm interested in results, not dogma. Now let's confront the controversies here. So you've got people like Beck and Fowler and Martin and so forth, who are big boosters of test-driven development, big proselytizers for it, and they've made some. They and their fellow travelers have made some really big claims for what TDD can do. So in one of Beck's books, I'm forgetting which one, I think it's Extreme Programming Explained, he makes a comment that these TDD tests allow you to refactor code with zero regression risk. Basically, refactor meaning change, right? I can go in and change the code and I don't have to worry about breaking anything because I've got these TDD tests. Now, this is an absolutely stunning claim because basically what he's saying is that somehow or another TDD tests are immune to a law of testing that has been known since the 1960s, which is that tests can show the presence of bugs but can never prove their absence. And this is a long established rule of testing, probably one of the first rules of testing, and it's related to the fact that there's just an enormous number of tests that you could potentially run. And so this idea that somehow or another TDD as a technique, regardless of who's using it, is going to deliver these tests that are 100% defect detection effective against a certain class of defects, specifically regression defects, is just, as I said, it's breathtaking in its boldness, and almost certainly incorrect. I mean, if you look at some of those of Capers-Jones's figures on the effectiveness of unit tests, typical unit tests are 25% effective against defects. The really, really good ones are maybe 50%. So that's nowhere near 100%. And by the way, put that up against a typical independent test team, which is generally going to get about 85% defect detection effectiveness. So, you know, I'm sorry, that just doesn't that doesn't hold water, and it is indicative of a lack of awareness of the limitations of testing that is really kind of calls into question a lot of other things that you know, those who are boosters of this technique would say, right? That they would, if they say something like that, then, you know, that really does kind of is a credibility issue for me with some of the other statements. The other thing that you hear people say is that TDD will clarify your thinking before coding. I'm not sure why expressing your thoughts as tests and as automated tests is necessarily going to clarify your thinking any more than expressing your thoughts with code would. I mean, because automated tests they're effectively, you know, they're code of a sort, right? They're a program that runs to test another program, in this case, or a piece of a program. So, you know, I don't see that the clarification necessarily happens unless people are following, you know, proven black box and white box test design techniques, especially black box test design techniques. I think if people are applying the proven test design techniques, then yes, there should be some clarification of the thinking before coding. But if it's just, you know, I've got something in my head, I've now written down a set of steps, and then I'm going to, you know, create tests for that. Well, I've already basically, in writing down the steps, I've already proceduralized my understanding of what the software is supposed to do. And so effectively, if I put myself into a box of a sort, locked myself into a certain approach to solving the problem, and now I'm writing tests, you know, I think you're, you know, again, I'm just kind of curious as to how much clarification is really going to come out of that. So I, in putting this presentation together, I did ask Beck if he would be kind enough to review and comment on these slides and some of my comments. And in spite of the fact that I have engaged in various Twitter exchanges with him before, and this is how I asked him, is on Twitter, because that's the only way I know to get a hold of him. So in spite of the fact that I have had some exchanges with him on Twitter before, and generally friendly and respectful on both sides, I didn't hear anything back. So now, you know, I'm happy if he gets wind of this presentation and he decides to listen to this webinar and wants to respond to some of these things, I'm happy to take those responses from him. I'm certainly not looking to slam him or Fowler or Martin or anybody else, but again, I think that there's some pretty big claims have been made. Now, Jim Killeen, who is a noted test-driven development critic, and actually posted a couple articles on my website to that effect, of one of them provocatively called Why Most Unit Tests Are Waste. I asked him to summarize his concerns, and so he sent me a lengthy email describing his concerns, which I will try to summarize here. And if you are inspired by what I'm about to tell you to try to get some more info from Jim about his concerns with TDD, I would encourage you to get in touch with him. He's usually pretty responsive and is happy to, if you ask him some questions, happy to give you an extensive explanation of his thoughts. So, but to the extent that I can make his case against TDD for him, one of the first things that he says, which I definitely agree with, is that TDD is not a testing technique. It's a design technique, and what's being produced are not necessarily tests, but automated design specs. Now, it's not a testing technique, but it does have all the weaknesses associated with unit testing. And if you read his articles, you'll see he goes into this in great detail. Certainly one of the problems is the author bias. Okay, so this is where this comes back to this clarification of thinking issue and whether that actually occurs. It's not there's nothing inherent in TDD that's going to force somebody to confront their mistaken views about how this module should be designed. I mean, it will help find implementation problems, but from a design point of view, you're coding the design into the tests. The tests themselves can't tell you whether that design is correct. So this is the classic author bias issue. There's whole groups of problems that simply can't be found when the tests are built using the same assumptions as the code has been built on. Now, another weakness of unit testing is that it is focused on individual objects, and it can't tell you much about how those objects interface with each other. It can't tell you anything about emergent system behavior. So things like integration bugs, you won't find those. Performance problems, security problems, reliability problems, likely to be pretty weak on those. So again, according to Capers-Jones, you should expect about a 25% defect detection effectiveness from unit tests, and there's no real hope in trying to push it beyond 50% because it just won't. There are certain kinds of problems that simply cannot be detected by unit tests, regardless of whether you could get the author bias issue off the table. Now, this is something that you really would want to go to Killeen to get more info on, because he's a professional programmer and noted authority on object-oriented programming and object-oriented design. And I know how to write C++ code, but I wouldn't consider myself by any means an expert on object-oriented test or object-oriented software design. But you'll notice that the way that we approached the e-commerce situation was we start off with an outline of what the system is supposed to, or what the module is supposed to do. Is it this, and then this, and then this, and then this? Well, in object-oriented design, it's supposed to be top-down and objects, built based on usage. And what Killeen is saying is, well, because of the way that you're writing down a set of steps, you're going to a procedural approach, which is bottom up. That's the classic, the way you would write C or Fortran or something like that, is you do a hierarchical decomposition of the problem down into little pieces, and then you write procedures that solve individual pieces of the problem, and that's what TDD is doing. He has some concerns about the volume of test code that's created and the amount of maintenance that would be required to keep those tests up and running. So, expensive. It's an expensive approach, he says. He says that the fact that you have this big growing inventory of tests is most likely going to give a false sense of confidence, and again, that gets back to the assertions of all of the bugs will be found, right? And no regression bugs can get past us. And notice also that this is a verification step at best. There's certainly no validation happening here. It doesn't demonstrate that the product is being built in such a way that will actually solve the user or customer's problem. Now, here again, something that you need to go to Killeen on for more details, some more references, but he's saying that that research that he's seen does not support any improvements in coupling and cohesion or reduce bug density in the code that's produced. So, again, in his articles too, you can find some references to these, but I'm sure he'd be happy to provide you with more references. So he sees it as an expensive technique with limited benefit. Okay. So, to conclude here, sorry, I'm just having to screw around with a Citrix interface a little bit. So as we saw at TDD, there's this sort of alphabet soup of stuff that happens out there with the ATDD, BDD, SBE, and this is likely just to get even more complicated. Rob Sabarin refers to all the DDs. There's certainly a lot of DDs in Agile. I mean, maybe we should come up with a few more. Requirements-driven development, RDD. But, it is one of the things out there. Hopefully now you've got a better understanding of what is meant by those and how they're different. Now, of course, what one person means by TDD is not necessarily the same thing that somebody else means by TDD. And, the Becks and Fowlers and Martins of the world can jump up and down and say, this is what TDD means. But I mean, words are just words, and people are free to use them to however they want. So, be careful when you're talking to somebody. If they say their organization uses TDD, don't assume that what exactly that means. You might ask them to describe that in a little more detail. And remember, just because the word test is in TDD doesn't mean it's actually testing. If it's done by a typical developer who's got limited knowledge of test design techniques and is entirely relying on their own concepts about how the module should be built as a way of creating the tests, and it's really not tests. Now, if you are able to if you have the skills, I would say if your organization is doing TDD, jump in there and help. You could certainly improve the defect detection effectiveness of the tests, get a better idea of what's being tested in the unit test so that you know what you should do in your system tests. It really wouldn't take long for somebody, even with no programming experience, to get to the point they had basic competence and could participate effectively in this process. So if you're listening to this and going, oh, he's going to be talking about more technically skilled people than me, well, not necessarily. Don't put yourself down. And again, when you hear people talking about TDD, especially if they're making big claims for it, bring your industrial sized bag of salt to go with that. There is certainly plenty of controversy, plenty of debate about what TDD can actually do for you and what it is doing, what it isn't doing. I don't think there's any value necessarily in getting into this into an argument with somebody. If there's developers in your organization that are strong TDD partisans, I don't see any profit in it for you to go and tilt the windmill, as it were, and go, hey, I just listened to this webcast by this guy Rex Black, and he says that you guys are, you TDD guys are full of crap. I think there's just no point in stirring up that kind of hornet's nest. As I said before, there's a lot of dogma here and a lot of sort of religious fervor. And it's on the development side. If you're a tester, you should just watch it with an amused smile and stay out of it. But just, the reason I bring it up is so that you are sort of immunized against some of the magical qualities that are claimed for this. Just because there's TDD doesn't mean you should let down your guard. That said, now I don't want to come across as completely skeptical here, and Killeen is very skeptical about it, and I published his articles on my website because I thought that it was useful to have another side of the debate. I think that there is value in automated unit tests and would want to see those present. If the way in which those are produced is TDD, and if it takes a certain amount of religious fervor, if you will, which is often accompanied by feelings of guilt when one does not live up to the high standard put forward by the high priests of the religion. If that's what's necessary to get developers to be very, very scrupulous about creating automated unit tests, then I'm okay with that. All right, so we'll go ahead and put the advertisement up here while I go through the questions, Q&A. It seems to have already generated a fair number. Stefano says, I heard also developers telling that it is cool, but it takes too long to write code using TDD. Yeah, I've actually heard that myself from one or two developers, where they've said, I like the idea, but it really slows me down. Now, the boosters of it would say, well, no, because it seems that way, but what's actually happening, since it's clarifying your thinking and shortening the debugging period, is that it should go faster once you've learned how to do it. Again, I don't know. I have done it a couple times myself in a classroom setting, teaching people TDD techniques as part of a larger course, and I did find that it slowed my programming down quite a bit. But that could very well just be because I hadn't practiced it. I'm thinking if you got good at it, maybe it wouldn't. But certainly that's out there, and I guess you can't really argue with someone's experience. If there are developers out there that are good developers and they're very efficient developers, and they've tried TDD and they find that it really slows them down, then that's what's true for them. Can't argue that. Now, Bill sent me this link. Bill, thank you for this, but I'm not really sure what this link is supposed to do. archive.vector.org.uk/art 10501120. I don't know what that is, Bill. Maybe you can pass along a little more information. I might be able to send that out to people. Let's see. So Amit says, as for TDD as an aid to clarification, you said you don't see how it does that. I've heard developers referring to that as a way to see things such as, I'm going to need some API call to do that, or reveal some interactions between parts. Getting to know this sort of thing before writing code seems to me like a good start of understanding how things work. Okay, well, if that's the case, I think what you're referring to is the part of the procedure, the part of TDD that involves writing out the procedure first. Which, okay, that I can see how that could clarify thinking, because you've thought through the procedure and written it down But, you know, that's, I mean, to me, that's not, you could do that. You could think through that procedure, write it down, and then proceed to write the code and create the unit tests afterwards. So to me, it's like, you know, the part that's clarifying there is not really what's essential TDD, I guess. But I don't know. Maybe I'm missing something. Notice that is one of the parts that Killeen objects to. You know, as procedural design thinking. So that's kind of an interesting debate. Again, probably more a developer's inside debate than anything else. Let's see. Lena says our developers have started doing unit testing, and it has helped prevent the smoke bugs. A smoke bug, I assume, referring to bugs that would be found during a smoke test that would render the system untestable. Also, she continues, our test department sends the dev department our test cases to review before they code. Yeah, I definitely like that. And I definitely agree that the automated unit tests have the ability to prevent the delivery of software so bad it's, you know, completely untestable. And as I said before, if TDD is the religion that people have to get in order for them to scrupulously create and deliver automated unit tests, then you know, I'm happy with them getting that religion. Though I don't necessarily have to believe in it myself. Okay, Amit says, as for TDD driving bottom-up design, I've encountered the idea of outside in TDD. I heard it referenced as the London School style. Does this type of TDD address the concern of perspective? And then Amit includes a YouTube video, a link to a YouTube video. I don't know. You'd have to really talk to you'd have to talk to Killeen about this. And I'm going to try to copy this link here, Amit, and send this out to everybody. Okay, well, huh. Shoot. Darn it. Oh, there we go. Okay. Yeah, here, I will, Amit, what I'm going to do is I'm going to send your comment and the link out to everyone here. I just did that. So for those of you who want to go look at this YouTube video later, you've now got the link. Yeah, as I said, I don't really know, and this is, you know, this is really more of a deal with Killeen and his concern. So I would suggest, if you're curious, you know, get in touch with him, ask him what his thoughts are on that. Whether that is one of his central critiques of TDD or whether that's more of a collateral damage, as it were, I don't really know. I haven't really talked to Jim about this, like where they stand in order of priority for him. Stefano says, this webinar reinforced my opinion on TDD. Huge effort, easy to do it wrong, low benefit. Still, many see it as the magic that will improve code quality and push for it, most probably because it is sold together with Agile as the way to do better development. Yeah, you know, I think, so, you know, I want to be clear here. I am a huge fan of developers creating automated unit tests and including those automated unit tests in a continuous integration framework. That's different. My position is different than Jim Kileen's position. He does not believe that there's a whole lot of value in that. I do believe there's value in automated unit tests. I grew up as a programmer creating unit tests, though we didn't call it TDD, and you didn't write the tests first. You wrote the tests afterwards. But I was always of the opinion that you code a bit, you know, code a little bit, test a little bit, code a little bit, test a little bit. which is sort of the same basic idea of what's happening here, just the tests are coming first. But I think if you adopt this whole scale, it could very well be a pretty big overhead. And the thing I worry about with that, I guess, more than anything else is blowback, in the sense that if organizations try TDD and it doesn't work, they see it as expensive, a lot of overhead, not a lot of value, etc. Oftentimes what happens after these fad bubbles burst is sort of an overreaction in the other direction, and it might lead to people deciding, oh well, we don't need to do unit tests at all. All unit testing is a complete waste of time, and then you lose out on the scenario that Lena was describing, which is that the quality of the code that's being delivered does improve when there are unit tests, regardless of how those are created. So hopefully that backlash effect will not be as pronounced here, and organizations kind of decide, well, TDD as strictly described by sort of the high priests, it doesn't work, but it is still valuable to have automated unit tests and to use code coverage techniques to make sure that those automated unit tests cover what they need to cover, etc. But I certainly agree with you, Stefano, in that there is an endless quest for some sort of magic bullet, magic dust that is going to solve software quality problems. And to the extent that TDD is seen as that is, of course, not helpful. Gary's asked, and good to hear from you, Gary. Glad you could make this. Are Jim Copleen's thoughts confirmed with some statistical data or metrics? Again, I think you'd have to ask him. I know he did reference some empirical studies that show that that Beck's claims of improved code quality and reduced bugs are not supported by empirical evidence. But you need to go directly to the source. Notice that some of the things that he's saying are really qualitative critiques too, not necessarily connected to code quality, like the issue of top-down versus bottom-up design and whether the design technique is appropriate. I mean, that's just that's a whole separate question, which is basically, does TDD result in writing code that's less object-oriented and more procedural? That's a stylistic question, right? So, but again, I'd say go to him, go directly to Jim and see what he has to say. Let's see. Amit says, a question, if TDD is a development technique, why invest so much time in stating it isn't testing? It doesn't claim to be proper testing. Well, for one thing, it's got the word test in it. So the people who chose to name it that really are the ones that you might want to direct this question to, Amit. Why did you choose to put the word test in a technique that is not necessarily going to be testing at all, and is not even going to be built using basic principles of testing? And then the other part of that is, why the fantastical claims of 100% defect detection effectiveness, at least against regression bugs. And if you're claiming that, well, you're sort of claiming that it is a kind of a test, I would say, to the people who make such claims, and a rather magical kind of test indeed, because it has a power to find 100% of the bugs, which no other test in history has ever been able to do. So, again, I think, Amit, your question really would be better addressed to Fowler, Martin, and Beck, who, again, these are the guys who named it Test-Driven Development and have been promoting it under that name rather than, stepping back and going, well, it really should be called EDS, Executable Design Specifications, rather than TDD. Let's see. Stefano says, I saw skilled teams of developers doing TDD right and get benefit from it, but as they are skilled, they already produce good code before introducing TDD, so they maybe didn't need it at all. Yeah, I mean, I guess you'd have to ask the developers whether, they felt like it was giving them benefit. Again, this is one of these things of, you can't really argue with someone's experience report, right? I mean, if what their experience is what their experience is. If they got value from it, then, good for them. As I said, if this is if getting this TDD religion is the way in which developers become convinced that they absolutely have to write automated unit tests, then again, I see that as a small price to pay. Though I'm not joining the religion or participating in it. I'm just pointing out that it helps. Let's see. Mary says, does unit testing in general and TDD in particular create a large code maintenance technical debt? Well, that's a very interesting observation, Mary. I guess you could argue that it does, in the sense that it makes changing the code potentially more expensive. Now, the boosters of TDD, Beck, Fowler, Martin, etc., would say, well, no, it actually makes the changing of the code less expensive because it lessens it reduces the regression risk associated with changing the code, because your tests are a way of helping to prevent these kinds of problems from getting past you. But I mean, yeah, certainly, just from a common sense point of view, if you're now basically, let's say that the code, just setting aside, Colleen's claim that the code can be, the test code can be as big as the production code. Let's say it's a 50% overhead. Well, yeah, I mean, now you're basically saying that there's this additional code, which is not shippable code, and I say that the best measure of progress is running software, but that's running software that would be delivered to the customer, right? This is, this is just, it's an overhead, right? So yeah, I mean, it would seem that just by sort of common sense analysis, that it would indeed tend to slow things down and act as a impediment to making change to the code, which is of course ironic, given that the veritable mantra of extreme programming from which TDD came is embrace change. So the irony is not lost on me anyway. Let's see. John says, thanks, Rex. Will you let me know if there's a recording available of this, watching it now and enjoying the great information you're presenting? Well, thank you for the kind words, John. Yes, the webinars are all recorded, and they are posted on our website generally within about a week or less. They are on the digital library, so what you do is you go to the website, you go to the resources tab, and then from there you navigate to the digital library, and you'll find the MP4 posted there. There's also an audio recording, and since this is excuse me, really more of a talk than a audio-visual presentation. In other words, the slide content, you don't necessarily have to look at it while you're listening to me. So this is one of those ones where if you want to download the MP3, just pure audio, you can do that. We've got an RSS feed on our website, and it's also published on iTunes, so you can listen that way. So Bill, regarding his URL, he says, I sent links to an APL test tool available in the UK. You implied that test tools for APL, you called it bizarre, may not exist. I'm proven wrong. Okay, so I appear to have offended you, Bill, in my comments about APL. I guess what I meant was maybe unusual or seldom used would be a better word. I think we can all agree that there's not a whole lot of APL development going on. For those of you who have no idea what Bill and I are talking about here, there is a programming language called APL, which I'm not making this up, stands for a programming language. It's developed by IBM. It's a very powerful language for doing various kinds of mathematical work, but it really, I think it's like Forth in the sense of it requires you to sort of bend your brain in very interesting ways in order to be able to think like it wants you to think, to express yourself in APL. Anyway, yeah, that's it. I guess, though, Bill, you just reinforced my point even further, the point that I was trying to make, which is that regardless of the programming language you're using, it's almost certainly the case that there are going to be some unit testing tools available for you to help. So if you hear developers in your organization saying, well, we'd love to do TDD, but we can't because, we're in this obscure language and there's no such thing as a framework for it, then, I'd say spend 5 minutes on the web and you'll probably find it. Let's see. Gary says, I have seen doing a TDD and then TDD successfully. Which is enforcing top-down construction? What do you think? I'm not exactly clear, Gary, on the question here. So the top-down design issue, top-down versus bottom-up. Jim Copleen's critique here is on the design thinking that's driven by TDD. ATDD, since it's talking about behavior, is not going to lead to any particular kind of design or implementation decisions. It doesn't. You don't care. You're just saying, under these set of inputs, I should see this set of outputs, this behaviors. So I would think ATDD is neutral with respect to design and implementation, and TDD has the potential to influence it just because it is basically a way of thinking about design. Bill says, no offense, I was an old APL hacker decades ago doing mathematical physics programming. Haven't used it since. Yeah, I'm sure for mathematical physics programming, it was probably really great at that. And once you've wrapped your head around how APL wants you to express your ideas, it's probably really powerful. I can't imagine trying to build a video game with it, but mathematical stuff, yeah, absolutely. So, by the way, so for those of you who are curious about what this whole discussion between Bill and I has been about, I'll send you that link and you can take a look at it. I got a comment from John here. Thanks, Rex, regarding the posting of the recorded webinar. You're quite welcome. They're all out there. God, however many there are. We've been doing this for over 5 years now, so once a month. So there's 60 plus recorded webinars out there that you can always listen to, and of course they're all free. Now we are launching our new website, which is going to be mobile friendly and have an improved look and feel. It might kind of, if you're used to our existing site, as clunky as it is, if you've sort of mastered it, it might take you a few days to figure out where everything is, and I'm going to have to figure out where everything is too, but hopefully it'll be easier to find these recorded webinars. Okay, well, good questions from the audience as always. I'm glad to see the usual regulars here. To close this session, a little bit more about the resources available. These free webinars run once a month on our website, rbcs-us.com. You'll be able to find the latest listing. We have the listings all the way through the end of this year. If you'd like a special webinar presentation for your company only, this webinar or on any other topic related to software testing, send an email to info@rbcs-us.com or contact us via our website. If you don't already receive our regular free newsletter, sign up at rbcs-us.com. This will get you valuable discounts on consulting and training services. Some of those discounts can be as big as like 20%, so it's nothing to sneeze at. You also get a regular newsletter that includes a featured article on software testing and quality and news about what RBCS and its partners are doing lately. We are on Twitter, as you can see here, and on Facebook, as you can also see here. RBCS is the professional Twitter, the company Twitter, and the Leica Test Dog is my personal account. So just to keep that in mind. Certain non-test related things end up on the Leica Test Dog, which you might like or you might not like. But the RBCS page is all focused on stuff related to what we're doing and testing. Do remember to check your email over the next couple days because you could be the lucky winner of a free e-learning course from us. You were registered for the random drawing simply by attending this free event. As I said, Digital Library has recordings of these webinars. There are also probably a dozen or so videos on topics like risk-based testing. So, check those out. Again, all this stuff free. We have our podcasts, which are the audio versions of the recorded webinars. And we also have the RBCS channel on YouTube where you can see videos and recorded webinars there as well. We offer these free resources as a service to the software testing community because at RBCS we are a not just for-profit company. Concludes the webinar. Thanks for joining us today. See you next time around.